Go.
Okay, kids. Today's lesson is all about heat transfer.
Loud.
Okay, heat transfer. Well, what does it involve? Well, things transfer heat in two ways. Let's imagine a cup in a room. I put hot water in there. The cup will begin to cool down. In other words, the heat will be transferred from the cup and the water out to the surroundings. Okay, so we'll be looking at things cooling down. The other scenario might be if we put something cold, very cold, into this cup. So the cold water. Yeah, so we'll put that in. In this case, the room, which is usually at around 20 degrees Celsius room temperature, will cause the cold water, the cold drink, to warm up. In other words, heat is transferred into the water. So we'll be looking at the mechanisms, the ways in which the heat actually moves from where it's hotter to where it's colder. Okay, so there has to be a temperature difference between two areas for that to happen. Okay, so the three main methods of heat transfer that you need to know about involve two that begin with the letter C and one beginning with the letter R. First one, conduction. Second one, convection. Third one is called radiation. Okay, right. Well, in any question, if the method of heat transfer is conduction, then you need to know that it involves a solid material. Okay, solids. Right. In convection, this involves what we call any material that is fluid. In other words, it flows, e.g. water, a liquid in other words, yeah, and air, which is a gas. So it involves liquids or gases. Right? Now, you can never, ever stop an object from transferring heat. Okay? It will happen, and it will happen because of this third method of heat transfer, which can really, really confuse many of you. And this is basically infrared waves. Unlike the two C's, conduction and convection, you don't need particles to be involved in this method of heat transfer. Okay? Right. So what do you really need to know if you now want to move the game on? Well, in solid materials we deal with either metals or non-metals. That's really the two types of materials you need to be aware of. Okay? So if the question talks about metals or non-metals, we're dealing with conduction. Metals conduct heat very well. Non-metals don't conduct heat very well. They're more like insulators. Okay? So metals are said to be good conductors, whereas non-metals are said to be good insulators. Okay? Right? So, at the highest level, boys and girls, for conduction, what you need to do is to be able to explain why metal materials make good conductors. And the plain and simple answer is that metals have something called delocalized electrons. And these tiny, tiny subatomic particles can carry the heat energy through the metal from one end to the other, from the hotter end to the other, and thereby the heat energy is transferred more quickly. Whereas the non-metals, unfortunately, they don't have these delocalized electrons, so they can't go anywhere. The heat takes its time getting from the hot end to the cold end. That's basically it. Okay, that's conduction. Convection. Often, kids will answer, and we'll say, what happens to heat? And they'll always say, heat rises, which it does. But then again, if you sit on the chair becomes warmer. The heat hasn't risen, it's gone downwards. Heat simply transfers to the surroundings in many different ways. In convection, indeed, hotter fluids rise and colder fluids come in to replace the hotter fluid, which has now vacated, moved away from that area of space. Yeah? You can't have empty space in this room. As soon as some hot air, for example, above a radiator goes up, colder air must immediately come in and replace it. This works by something called a convection current. Okay? Basically how we get, well, the windy conditions that we have in the country. It is basically nothing more than lots and lots of giant convection currents. What causes it? Well, let's change that. Let's use blue to represent the colder fluid. So, the cooler or colder fluid, they are said to be more dense. That means the particles in fluids, when they're cold, the particles are closer together, more tightly bunched up. So they feel heavier, then they fall. On the other hand, any warmer fluids, the particles spread out. They are less dense. That means compared to the colder fluids, which are more dense, these particles here feel lighter. So as a result, they move in the opposite direction, upwards, hence the term heat rises. And as they move, they take the heat energy up with them. Okay, so remember this. Conduction, solids. Convection, liquids or gases. Final one are these pesky infrared rays, these infrared waves. Any object that is above the temperature of its surroundings will simply give off infrared waves to the surroundings. Okay? And this simply is a form of energy that goes anywhere. It can travel through empty space. It is how the sun warms the earth, through the billions of miles of empty space. Infrared waves that come along and warm up our planet. Okay? So, what do you need to know about this? Well, you need to know that, first of all, in this case, let's assume we've got the hot water. Let's assume that this water is at 80 degrees Celsius. Ooh, that's warm. Okay? Right? So, Kiddlywinks. If this cup was a dark colour, say a black cup, that surface, that colour, will make that cup lose more heat energy by infrared, because more infrared waves are being lost. Those are the infrared waves. Okay? Right? So a dark surface is what we say, a good. Now, to give out means to emit. That's just the posh word of saying, hey, we're leaving, okay? They are said to be good emitters of infrared, okay? Or radiation, right? On the other hand, if that cup was made of a shiny, a bright coloured surface, the cup would lose the heat more slowly. And that's because bright, shiny surfaces don't give out the heat, the infrared, as quickly. So they're said to be poor emitters. Remember the word, emit means to give out, okay? Now, over the years of teaching, here's where the confusion always gets most kids. They can quote that. That is not a problem. What is a problem is then you get given a situation like this one here on the right. Remember, we've got the very cold water in here. So let's say it's come out of the freezer, or the fridge. So it's likely to be at a temperature of around 5 degrees Celsius. So, in this case, the heat is going to be transferred from the room into the cup and into the cold water, which will end up warming up. If I have the same black surface cup again, in this case, this isn't about emitting infrared out. In this case, the infrared that's in this warm room is being absorbed into the cup. It's not the other way around. It's being absorbed in. Okay? So infrared from the room is being absorbed inwards. Okay, that's the way the energy is going. And do you know what? It's exactly the same situation here. Instead of talking about emitting here now, we are talking about absorbing. Okay? So the same dark surface, the same black cup, will actually be the better absorber in this case, in this scenario, of infrared. Okay? It is why if you get in the summer, you get into a car with a black interior, it feels warmer than the same car which has a brighter, say for example, a grey or a beige interior. Okay? Right? So, dark surfaces make good absorbers of infrared. But the same thing now says that brighter surfaces are poor absorbers. Okay? Right? In this case. So if I have a white cup, the contents of that cup will take longer to warm up. They will stay cooler. It is the whole idea behind why most modern fridges are white. It is the basis behind why you have these cool boxes which tend to be white on the inside surface. So they do not absorb the infrared. And that, in a nutshell, is heat transfer. Thank you for listening.